Hello students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So now, what is essential to crack an exam? Only completing the syllabus, is it enough? No, right? So after completing the syllabus, it is very important to attempt the previous year questions, okay? And many of you have requested to get chapter-wise PYQs. So this is very important to understand the level of examination, what type of questions are asked from the chapter in the KCET examination, right? So yes, today we have come up with the PYQs of last 10 years from the chapter solutions, okay? So we have taken all the top 30 questions from the last 10 years, that is 2014 to 2024. All the types of questions have been included, and you can expect similar questions in your KCET 2025 examination as well, okay? So what is your task? Now, if you have studied this chapter solutions already, okay, then you can watch this video and start solving the questions with me, okay? And if you haven't prepared this chapter completely, the playlist, I have completed the entire PU2 syllabus for your KCET examination. So the playlist link will be there in the description section. You can go there, check the playlist, complete this chapter solutions from those videos. After that, come back and solve the questions with me. Okay, so yes, now let's get started. Please be, this is very important. Solutions chapter, mostly it's a high weightage topic. You can easily expect 3 to 5 questions from this particular chapter. So, and the questions will be of the type that we are going to discuss today. Okay, so without further delay, let's get started, and please be seated with your notebook, pen, and without calculator. Okay. Yes, so now let us start. And one more thing, please join our WhatsApp channel. Link will be there in the description section. You can go there, join the WhatsApp channel, so that you can get access to all this notes in the PDF format. Okay, fine. So we'll start with the first question. So I have divided the the chapter in different topics, like we have concentration terms, solubility, colligative properties, right? So we have divided the topic, and then we have taken questions, okay? And I have also told you about the level of question, how much time you need to spend in this type of question, so that you will have a general idea that whether in like how to solve, how much time you need to dedicate. If you are dedicating more than that much time, then you must do more practice. Clear? So let us see the first question here. Okay, so this question was asked in 2022 examination. An aqueous solution of alcohol contains 11 gram of water and 414 gram of ethyl alcohol. The mole fraction of water is, okay? Now this question, I'll say it is very easy, okay? Direct formula based question, okay? And formula used is your mole fraction and common mistakes. So generally, I think in this type of question, students do not do any mistake like with concepts and all. It is only thing you should be careful with the calculation, okay? Next, time taken, because it has some calculations involved, so 40 to 45 seconds you need to do to solve this question, okay? But I'll be explaining you, so I'll be taking more time, but yes, you need to solve this question within 45 seconds, okay? So now let us see. And one more thing that you might do mistake here is, see, ethyl alcohol, generally the solute mole fraction is asked in the question, but here they have asked you the mole fraction of water, and water is a solute here because it is present in less amount, and 414 gram of ethyl alcohol, that is the solvent, okay? So if you know what is the mole fraction of, I'll write mole fraction of water, then I need number of moles of water by number of moles of water plus number of moles of ethyl alcohol. Right, now what will be the number of moles of water here? 11 by 18, right, given mass by molar mass. Then what will be the number of moles of ethyl alcohol? So that will be 414 divided by its molar mass. Ethyl alcohol molar mass will be C2H5OH, right? So 12 2s are 24, 24 plus 6 we have 30, 30 plus 16 we have 46, right? So 46, okay? So now you need to solve this, put this data in the formula. So what I'll get here, x of water will be equal to, we can keep like 11 by 18, okay, divided by, you have 11 by 18 plus 414 by 46. Okay, so now one thing you can see here, that mass of water is very less. Okay, 400 grams of ethyl alcohol is there and mass of water is only 11 gram. So that means its mole fraction will also be very less. So you can easily eliminate these two options, right? 0.7, like more than 50% it is saying that it is water, right? So that is why we can eliminate this option. Now if you do the correct calculation, you will find that the correct answer for this question will be option number C here. Okay, so now you have to, that the formula that is required here is number of moles of A by number of moles of A plus B. Okay, I hope this question is clear, very direct question. Now let us move towards the next question. Solubility of gas in a liquid increases with. Okay, so this question has come from the next topic, that is solubility. Now here if you see, this question is super easy. Okay, just you need very theoretical question. So theoretical question you need to do within 10 to 15 seconds. So time allotted here is 10 to 15 seconds. If your concept, sorry, this is wrong, so no formula is used here. If your concept is correct, then there will be no chance of doing any mistake in this particular question. Okay, so if solubility of gas in a liquid depends on pressure and temperature, increase of pressure, solubility of gas will increase. If you increase the temperature, the solubility will decrease. So what is the factor? Pressure increases and temperature decreases, solubility of gas in liquid increases, right? So increase of pressure and decrease of temperature. So correct answer is option number A. Okay, next question. Question number, so Henry's law about the solubility of gas in a liquid with respect to pressure, that is given by your Henry's law, which says that the amount of gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas. Okay, so now let us see the next question. So yeah, so this question is, like I'll say, difficult. Okay, first we'll read the question. Henry's law constant for the solubility of N2 gas in water at 298 Kelvin is 1 into 10 to the power of 5 atm. The mole fraction of N2 in air is 0.8. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atm pressure is. So many datas are given. I know if you read at one time it will get very confused. Even I got confused after reading this question for the first time. You need to understand what it is exactly asking. See, let us read one by one now. Henry's law constant for the solubility of N2 gas in water is given. Okay, Henry's law constant, very simple value we know. So KH value is given. Okay, so this question was asked in, okay, first let us talk about this question. This question was asked in 2021. Okay, and the level of the question, I'll put it in the difficulty level because it is little, it takes time for you to understand what exactly the question is asked. Next, the formula here are the formula required are partial pressure and mole fraction, and where you can make the mistake because two pressures are given, so it is important. You may misinterpret the question. Okay, so there is a high chance that many students may not understand the question correctly. Okay, next it will take more time because we will need some time to first understand the question if you haven't prepared such questions before, and then if you start solving it, at least 2 minutes time will be required for this particular question. Okay, so now let us start. KH value is given to us 10 to the power of 5. Okay, mole fraction of N2 is given. Okay, mole fraction of N2 is 0.8. Let me use a different color here. Yeah. Next, the number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atm pressure. Okay, so from the mole, if KH value is given, so you can easily think that, okay, Henry's law formula has to be used. So we know that Henry's law formula is what? P of the gas is equal to KH into mole fraction of the gas, and I know, okay, mole fraction of the gas is given to me, right? But here you have to see number of the moles fraction of N2 in air is 0.8. Okay, in the air the mole fraction of N2 is 0.8. Then if the pressure is like then at 5 atm total pressure, how much N2 will dissolve in water? In how much water? In 10 moles of water. That is the question. So now you can just draw and imagine this one. See, this is water and you have 10 moles of water. Okay, the pressure in the atmosphere is 5 atm. Okay, and the molecules of N2 here is the mole fraction of N2 here is 8. Okay, 0.8. Clear? Now they are asking how many molecules or how many mole fraction or how many moles of N2 will dissolve in 10 moles of water. For this, if you think, the formula is like this. Okay, is this 5 atm the partial pressure of nitrogen? No. Here is what many students will do the mistake. This pressure 5 atm is the total atmospheric pressure, but according to Henry's law, the solubility of a gas in a liquid depends on its partial pressure. Just now I have shown you the statement. You can see the solubility of a gas in a liquid is directly proportional to the partial pressure of that gas, right? So we need the partial pressure of N2, but here 5 atm is what? Total pressure. So how to solve it? The first thing we need to calculate is the partial pressure of the N2 gas. So how to calculate that? Pn2 is equal to mole fraction of N2 into P total, right? So mole mole fraction in the air, because it is present in air, so that is 0.8 into total pressure is 5, so I'll get 4 atm. Okay, so I got this value. Partial pressure of the gas or partial pressure of N2 is 4 atm. Okay, so now if I substitute here, 4 atm is equal to KH is how much? 10 to the power of 5. Okay, into X. X is what? Number of moles of gas, so number of moles of N2 by number of moles of water, and that is given to you as 10. Okay, so now if I solve this, I'll get 4 into 10 to the power of minus 4. So correct answer will be option number A for this question. Okay, so here you need to know the formula of pressure of the gas, that is Henry's law, and you should also know the partial pressure formula, that is P of the gas is equal to X of the gas into P total. Okay, clear? Now next question, choose the correct statement. Again a theory based question. Within 10 to 15 seconds or I'll say 5 to 10 seconds you need to select the answer. Question was asked in the year 2021 and this is an easy question, Henry's law. Generally if your concepts are clear, you should not do any mistake in this particular question. Now KH value is same for a gas in any solution. No, that is not there. Higher the value of KH, more the solubility of the gas. So if you remember, P is equal to KH into X, and this X represents solubility, right? So what will be the value of X? P by KH. So if KH is more, KH is less, solubility will be more, means inversely proportional. So higher KH value means more solubility. This is also wrong, this is also wrong. KH value increases on increasing the temperature of the solution. Now see, if I increase the temperature, what will happen to solubility? If you remember, if you increase the temperature, solubility of gas in a liquid will decrease. So when you increase temperature, solubility decreases. Okay, so if you increase temperature, solubility will decrease. If solubility decreases, KH value will be increasing. So I can say that if temperature increases, KH increases. So yes, this is a correct statement here. Okay, next question. Again this is also very easy question. KH value of argon, carbon dioxide, formaldehyde and methane are respectively given in the increasing order of solubility of gas in a liquid. So this question was asked in 2021. Easy question. Again Henry's law. If your concepts are clear, then this should not be any mistake here. Okay, so you should know what? KH is inversely proportional to solubility, right? So whosever KH value is the least one, that will be more soluble. So you see we have 4 gases: argon, carbon dioxide, formaldehyde and methane. So this is argon value, this is carbon dioxide, and you see this is the least one, right? 40.3, 1.67 and here into 10 to the power of minus 6. So this is your formaldehyde. So formaldehyde will have the least solubility, formaldehyde will have the least value. It is having the least value, means it should have the highest solubility. So this 3 will be at the end, so we can eliminate these 2 options immediately. Okay, now you see these 2 are also same. So after 3, which one should come? So if you see, the next value is 0.413, right? 0.413 is your 4th one, that is methane. So after 3, 4 will come. So correct answer will be option number A. Okay, This is how you need to find out immediately. So eliminate is immediately, always try elimination method wherever it is possible. Okay. Now let us go to the next question. Okay, 5.5 milligram of nitrogen gas dissolves in 180 gram of water at 273 Kelvin and 1 atm pressure due to nitrogen gas. So you see here it is mentioned that this 1 atm pressure is due to nitrogen gas, means PN2, the partial pressure of nitrogen is 1 atm. Okay, so the mole fraction of nitrogen in 180 gram of water at 5 atm nitrogen pressure is approximately. Okay, so now if you see this question, also I'll say little moderate. If you think a bit, you can easily do it. Question was asked in the year 2014. Okay, now see, if the pressure, see what is saying, 5.5 milligram of nitrogen gas dissolves in 180 gram of water at 273 Kelvin and 1 atm pressure. So if they are saying that if the pressure is 1 atm, how much nitrogen can be dissolved? 5.5 into 10 to the power of minus 3 gram. I converted milligram to gram. In how much water? In 180 gram of water. Okay. Next, the mole fraction of nitrogen in 180 gram of water at 5 atm pressure. So they are now asking, if the pressure is 5 atm, okay, then how much nitrogen or how much mole fraction of nitrogen can be dissolved in 180 gram of water at okay, the same temperature is not mentioned, that means the temperature is also same. Okay, so they are saying, we know if we increase the pressure, solubility will increase. So at 1 atm, this is how much is dissolving. Then if I am increasing the pressure to 5 atm, then how much will dissolve. Okay, so that is very simple one. You can use the formula. We have suppose we have P1 is equal to KH into X1, right? Same gas means KH value will also be same. P2 will be equal to KH into X2. So we can equate both of them, right? So I'll write like this. P1 by P2 is equal to X1 by X2, right? We can write like this. P1 by P2 is equal to X1 by X2. Okay, so now we need to find X1 value, right? What is X1 value? Number of moles of nitrogen in the first condition, that is at 1 atm. Okay, so how much gram of nitrogen? 5.5 into 10 to the power of minus 3 gram divided by 28. Nitrogen molar mass is 28, given mass by molar mass. Then you have number of moles of solvent, so that is 180 gram divided by 18, right? You remember this formula, N of N2 by N of water, right? N of N2 is 5.5 by 28, N of water is 180 by 18. So I have just written it like this. We'll get 10 here. So I can write is 5.5 into 10 to the power of minus 4 by 28, that is X1. So now let us substitute here. P1 is 1 atm, P2 is 5 atm, X1 is 5.5 into 10 to the power of by 28 into 10 to the power of here 1, so 10 to the power of minus 4. Okay, now if I solve this, okay, and then we have here X2. So what is X2 value now? X2 value will be 5.5 into 5 by 28 into 10 to the power of minus 4. Okay, now if you see how much we'll get, 5 5s are 25, 27.5 by 28. So almost this one will be somewhere around 1. So 1 into 10 to the power of minus 4. Okay, correct answer will be option number D here. Clear? Okay, again the same Henry's law formula you need to use here. Okay, now let us see the next question. So the vapor pressure of pure liquid, so we have come to the topic now, Raoult's law. Okay, Raoult's law formula, remember, P total is equal to P naught XA plus P naught B XB. Okay, so the vapor pressure of pure liquid A and B are 450 and 700 mm of Sg at 350 Kelvin. Okay, respectively. If the total vapor pressure of the mixture is 600 mm of Sg, the composition of the mixture in the solution is. Okay, so now here if you remember what is P total formula, okay, let us talk about the question. It was asked in 2021. It is not difficult, sorry, I'll tell it is a moderate question. Okay, Raoult's law formula application, you may do it little wrong because here one of the component is not given, and time taken should be around 45 seconds to 1 minute. Okay, now let us see the question, what values are given to us. We have P naught values, right? P naught of A is 450, and P naught of B is 700, right? And we have, we'll substitute it, total pressure is 600, okay? And let XA and then XB will be 1 minus XA, okay? So we can calculate this one, P total 600, okay, is equal to P naught A XA, so 450 XA plus we have 700 into XB. In place of XB I'll write 1 minus XA, right? This is what many students might not get it at that point of time directly in the point of exam. So XA plus 700 minus 700 XA, and here we have 600, right? So we can solve this. 600 450 minus 700, right? So we will have 250 minus 250 XA plus 700. So I'll take this one to this side, so I'll get minus 100 is equal to minus 250 XA. So if I solve this, we'll get 100 by 250 is equal to XA. So cancel, 5 2s are 5 5s are, so 0.4, right? So XA is equal to 0.4, that means XB has to be 0.6. Correct answer will be option number A here, okay? I think it's clear the solution, okay? The formula here is, you can see P total is equal to P naught B plus P naught A. I'll just erase this one so that you can see the formula. Okay, so in terms of one component if you write, then the formula will become like this, okay? Clear? Now we'll go to the next question, question number 8, okay? Solution A contains acetone dissolved in chloroform and solution B contains acetone dissolved in carbon disulfide. Solution A has what? Solution A has what? You have acetone in chloroform, okay? And solution B has acetone in carbon disulfide, okay? The type of deviations from Raoult's law shown by solution A and B are respectively. Question was asked in 2019. This is easy question, but it is theoretical memory based question, so easily you need to solve it within 10 to 15 seconds if your examples are very clear, okay? So topic is positive and negative deviation. You might get confused in the examples. So what is the learning for this chapter? For this ideal and non-ideal solutions, learn the examples, okay? I'll write a tip here. Please learn means you have to mug it up. Learn all examples, okay? Then this question will be of 2 seconds, like 5 to 10 seconds, you can easily solve this question. So now if you see the first one, here what will happen? Here there will be bonding will be there, hydrogen bonding, intermolecular forces will increase, so this will have negative deviation. So we have this option, we can eliminate first two, and here there is no further bonding, that is positive deviation. So correct answer for this question will be option number D, okay? Next, mixture of phenol and aniline shows negative deviation from Raoult's law. Phenol and aniline, okay? Negative deviation, that is due to the formation of. So if you see phenol and aniline, question was asked in the recent year 2024, and in 2024 so easy questions have been asked from solutions chapter. The only thing is you need to remember the examples, okay? So now this was a very easy question, again ideal and non-ideal solution. There is no chance of any mistakes if your examples are correct, okay? Time taken, I'll give 10 to 15 seconds is much enough than this. So due to the formation of what? Intermolecular hydrogen bonding. So answer has to be option number C here. See, if the negative deviation is happening, that means what? What does negative deviation tells you? Negative deviation means that the AB interaction is stronger, right? AB interaction is stronger. Now AB interaction will become stronger when they have intermolecular hydrogen bond. So correct answer is option number C here, okay? Next, for an ideal binary liquid mixture. So here Question was asked in 2014. Again, it is an easy condition for ideal. Generally, there should not be any error if your concepts are clear. 15 seconds is more than enough for this question. Now, first of all, you should remember that for any type of process, delta G mix is always less than 0. Okay, any mixing process, okay, delta G mix is always less than 0. So, we can eliminate these two options. Okay, now if you remember, for ideal solution everything was delta H mix, delta V mix is equal to 0, but delta G mix, you should remember that delta G mix for ideal solution is always less than 0. Non-ideal, ideal, any mixing process you are doing, delta G has to be negative. So that means now we have only these two options. Sorry, here there is, okay, so we have only one option, delta S mix. One second. Okay, we need for ideal solution, right? So delta G mix is greater than 0. This is correct, and delta S mix is greater than 0. Yes, so you have to remember these two things, that because when you are mixing, entropy will increase, and this is a spontaneous process. So these two things are correct for all types of solution. Now for ideal solution, what will be happening? Delta H mix is equal to 0 and delta V mix is equal to 0, right? So correct answer will be option number D here. Okay, why this is delta S mix is positive? Because entropy is increasing. Why delta G mix is negative? Because it is a spontaneous process. Okay, next question. Relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kg of water is 0.002. The molality of the solution is. Okay, so this is a difficult question. Okay, I'll tell you, the question was asked in 2019. A difficult question because there is a formula that generally you do not know. Okay, I'll tell you what is it. See, first of all, we'll see the relative lowering pressure is given to you. RLVP is how much? 0.002. Okay, and we have to calculate the molality of that solution. Now, what is the formula of RLVP? Delta P by P naught is equal to XB, right? So this value is what, according to the question, 0.002, that is equal to XB, right? So I can say that the mole fraction of the solute is 0.002, right? Mole fraction of the solute is 0.002. Now we need to calculate the molality. So here a formula you should know about molality. So this is your relative lowering of vapor pressure formula. Another formula of molality and this one, mole fraction, you should remember, XB by XA into MA into 1000. Okay, XB by XA into MA into 1000. Okay, so this is the formula that relates mole fraction and molality. Okay, please note down this formula, very important. Note down this formula. Okay, now let us do. So if this is XB, then what is XA value? 0.998. Okay, so what is molality now? XB is 0.002, XA is 0.998 into molar mass is 18. Molar mass of solvent, right? Solvent is what here? Dilute solution, water, right? So that is there into 1 second by W. Okay, so now we need to put into 1000. Okay, now if you solve this, okay, how much we will get? We have to just calculate this one. So this one you can say like 2 by 0.998 into 1000. So if you solve this, will be getting around 0.111. Okay, so correct answer for this question will be option number C. So I have written this formula, you can see here. 1 second. So this is the formula that relates the molality and molarity. Okay, molality and mole fraction. So you have to remember this formula. Okay, I hope all of you can check this formula. Okay, next question. Okay, 12th question. Vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is. Vapor pressure of pure water is given. Question was asked in 2024, recent question. Okay, 2024, and this is a moderate level question because it has calculation. RLVP is the formula. Error you can make in calculation, so time may require more than 1 minute. Okay, now how to solve this question, but I'll tell you a trick how you can solve this question within 10 seconds. Okay, so now you see, first of all, when you add a solute, okay, to a solvent, the vapor pressure decreases, right? So what is the pure water? 762 is the pure water. So the answer will be less than 760. So we can eliminate this option, okay. 3000, it will not increase, so directly we can eliminate this option. Now the vapor pressure decreases to a certain extent, okay, not like if from 760 it won't become 5, 6, 7 or 700, not like 70 it won't become. So that is why I can eliminate these two options also. 76 and 7.6 are too less, okay, that much decrease will not happen. There is a slight decrease in the vapor pressure. So from 750, the nearest answer 760, nearest answer is 752.4. So correct answer will be option number B here, okay. But I'll also tell you how to solve with formula, okay. So now if you want to use with formula, okay, so we have to use the traditional method. What is P naught? 760 minus P by 760, okay, into XB. So for XB, that is NB by NA. So NB is 18 gram of glucose by 180 gram, right, NB, and Na has to be molar mass, that is 178.2, okay, water, that is 18. So you need to solve this and calculate this P value, check, you will get 752.4 answer, okay. Next question. So this is the formula of relative lowering of vapor pressure, all of you have remembered by this time. Now let us go to the next question. So this question was also asked in 2024. Which one of the following pairs will show positive deviation from Raoult's law? Again, this is very easy question. Concept is your ideal, non-ideal, positive, negative deviation. Examples you should remember clearly. Time taken should not be more than 15 seconds for theoretical questions, okay. Now positive deviation means what? If I want positive deviation, then interactions should be weak, right? We need interactions, weak interactions, okay. So if you see in benzene and methanol, right, methanol was having strong hydrogen bonding, intermolecular hydrogen bonding is present, but when you add benzene, what happens? The intermolecular hydrogen bonding of these particles get disturbed, okay. So that is why this will show positive deviation, and correct answer is option number B, okay. Next we'll see the next question here. Okay, the rise in boiling point of a solution containing 1.8 gram of glucose in 100 gram of solvent is 0.1 degree Celsius. The molar elevation constant of the liquid is. Question was asked in 2022. This is direct formula based question, easy question, boiling point. You can make mistake if you like are not very serious. You can make mistake in like calculation error, but time should not be more than 1 minute because it's a direct calculation based question, okay. So now let us see how to solve this question. The molar elevation, we have this formula, delta TB is equal to KB into M, right. So if I substitute the values, delta TB, how much increase is there? 0.1 degree. KB value is how much? 1 second, the KB value we need to find out, sorry, okay. And M value is what? 1.8 of glucose means 1.8 by 180 into how much gram of water? 100. So these numbers are also very easy, numbers are given, 1000 by 100. So if I cancel, so I'll get 1 by 10, okay. So 0.1 kb by 10, so kb will be equal to 1. Just multiply this one here, we'll get 1. So correct answer is option number D here, okay. And elevation in boiling point formula, delta TB is equal to KB into M, where M is molality, KB is your ebullioscopic or this one molar elevation constant, okay. Next question. Solute X dimerizes in water to the extent of 80%. 2.5 gram of X in 100 gram of water increases the boiling point by 0.3 degrees Celsius. The molar mass of the X is, okay. So question was asked in 2020, okay. And the medium, I'll say the level was little medium here because you need to also incorporate the concept of Van 't Hoff factor here, right? Not direct elevation in boiling point, but Van 't Hoff factor is also included, so it will be little time taking here. Now time will be, but again you should try to finish the question within 1 minute. If you can immediately get to know that this question includes Van 't Hoff factor, right? Now what can be the common mistake? That is your ignoring of I value. Many people might not consider this I value, or they may not know the formula to calculate the I value, okay. So let us first see we need to calculate molar mass. Dimerizes, okay, so X value, the alpha value is 80%. So what is the value of I for association? Alpha value is equal to I minus 1 by n minus 1, right? So alpha value here is 0.8 because 80%. I value I need to calculate, I minus 1. Dimerizes means 1 by 2 minus 1, right? So how much I'll get this one? This one will be 0.8 is equal to 2 minus, so let us do the proper calculation here. Yeah, so we will get 0.2 and this 2 will be taken up. So how much will get? 0.8 is equal to I minus 1 into minus 2, right? So I can minus 0.1 is equal to I minus 1 into minus 1. So I can say 1 is equal to I is equal to 0.6 here, right? I'll get I value as 0.6, okay? So let me solve this one and write down together. I value is 0.6, okay? I value is 0.6, okay? Now let us see the calculation. We have this one, delta TB. Delta TB is equal to I into KB into M, okay? Now delta TB value is how much? We have 0.3, okay? I value is 0.6, KB value is 0.52, okay? Now M value, molar mass. So 2.5 gram of the solvent is there, okay? Molar mass is M into 1000, okay? 1 second, into 1000. Just a minute, we need to light little space here. Yeah, so delta TB is 0.3, I value is 0.6, KB value is 0.52, M value is, given mass is 2.5 into molar mass into 1000, okay, by mass of the solvent. So mass of the solvent is how much gram? 100 gram of water. Okay, so now let us see, we can cancel, this is 2, so molar mass value will be 2 into 0.52 into 2.5, this one we can cancel into 10, right? So how much we'll get? 2 into 2.5 will be 5, 5 into this one, 5 2s are 10, 5 5s are 25, 26, so you'll get around 26, decimal we have to put. So correct answer is option number C here, okay? Very simple, but yes, this part of calculation was little tricky, okay? You need to remember the formula here. Next question, after adding a non-volatile solute, freezing point of water decreases to minus 0.186 degrees Celsius. Calculate delta TB if KF value is given and KB value is given. Question was asked in 2015. Level of difficulty was moderate. Concept is both freezing point and boiling point, okay? The what can be the mistake here? If you do not understand the question, like application of formula, okay? Time required should be less than 1 minute for this question. Now you have to use both delta TB and delta TF formula. Okay, now let us see. We know delta TB is equal to KB into M, right? And delta TF is equal to KF into M. M we can cancel because it is the same solute. So what I'll get? Delta TB by KB is equal to delta TF by KF, right? This is the formula. Then what will I get? We need to calculate what? Delta TB. So delta TB is equal to delta TF, okay? 1 second, delta TB by, yeah, so we'll get delta TB is equal to delta TF by KF into KB, right? We can get this formula. If M is equal for both, then delta TB by KB will be equal to delta TF by KF. Now if I want to calculate delta TB, so delta TF by KF into KB. So this is the final formula that I have. Now I need to substitute here. So I'll erase this part, okay? So we got this formula, and now if we solve this, we need to substitute the data. So what is delta TF? Delta TF is minus 0.186, okay? Then by Kf. What is Kf value? 1.86. Okay, then Kb value is 0.521. Okay, now if you see, this part will anyhow will get cancelled. Okay, with some decimal it will get cancelled. So definitely the answer cannot be in this term, the answer has to be in this term. So we can eliminate option B and D. Okay, now if you see how much we will get, this is 1 by 10 will get 1 by 10 by this one will get 0.0521. Correct answer is option number A here. Okay, next question. Okay, this question is this question is medium to difficult level. Okay, little lengthy. It's not difficult, but it is lengthy. Question is little lengthy here. Okay, fine. Let us see. A sample of water is found to contain 5.8% of AB. Okay, molecular mass is 58.5, and 9.5% of XY2. So molecular mass is 95. Assuming 80% ionization of AB. So AB is having 80% of ionization. Question was asked in 2023. Okay, recent last year question. So it is a difficult question and it includes freezing point concept. Time required will be around 5 minutes. 4 to 5 minutes has been required because a lot of calculation is involved in this particular question. Okay, now if you see AB is equal to 80% the ionization, and for XY2 how much it is? For XY2 it is 60%, right? Yes. Next, the freezing point of the water sample you need to calculate. The freezing point of the water, pure water is given to you 273, and the Kf value is 1.86. Okay, now you remember when we add a solute to a solvent, the freezing point decreases, right? It goes down, so it will be less than 273. So it cannot be 280 or 281, so we can eliminate these two options. Now here you see the options are very close, 264 and 265, so you need to do the proper calculation here. Okay, I'll be telling you the method, how to do the like how to approach the question. Calculation part you need to check. Okay, so now see, and every time what is the, like, how is this question little difficult? Because here two solutes are added, AB and XY2. The questions that we have solved in NCERT or in other sample papers or anything, it always includes one solute. But if two solutes are there, then how to change the formula? So I'll tell you the formula. If there is two solutes, delta TF is equal to I, okay, sorry, not I, one second. The delta TF here is Kf into I1 M1 plus I2 M2. I1 M1 plus I2 M2. Okay, this is the formula that we need to use. Now let us see how. Okay, see, delta TF will calculate. First let us calculate I1 and I2. Okay, I1 M1, I2 M2. Let us solve this part. So if I1 I see, okay, for AB, okay, it was 80% association. So I can say alpha, what's the formula? Alpha is equal to I minus 1 by n minus 1 for dissociation, right? So now if I substitute the values, what will I get? See, alpha value is 0.8, okay, because 80%. I need to calculate, n, AB 2 ions will produce, so 2 minus 1. So that implies that I will be 1.8. Clear? Now coming to I2, if I want to calculate for XY2, and how much is this one? 60%. Okay, so how much will get alpha here? Alpha is equal to, again same thing, so we'll let us directly put the values here. So I'll get here 0.6 is equal to I minus 1. So I value will be, I need to calculate 3 minus 1. So it will be 2, 1.2. So it will get 2.2. So I value will be 2.2 here, right? So these are two important values. Let us encircle them and keep it in a box. Okay. Now we will calculate molality value. Okay. So this was, AB was how much? 5.8 gram. Okay. And molar mass was 58.5%, right? W by W. And this one was 9.5%, right? 5.8% and this is 9.5%. So what does that mean? See, mass of AB is how much? 5.8. Okay, The mass of the solution is 100 gram because it is W by W percentage. So what is the mass of solvent? Mass of solvent will be 100 minus 5.8, so that means almost 100.6, that is you can say 94. Okay, more than that will come, so 94.2, right? 94.2. Okay, that is the mass of the solvent. So then what is the molality here? Molality is given mass by molar mass, okay, into 1000 by 94.2. okay, that is the molality of this particular compound. Now if I see on this side W of XY2, okay, that is how much? 9.5. okay, then W of solvent, okay, so if you subtract 9.5 from 100 gram, the same thing, right? 100 minus 9.5 will be how much? We'll have 90.5. okay, we'll get 90.5. so now we will solve for molality. Again, given mass is 9.5, okay, molar mass is 95 into 1000 by 9.5. okay, so sorry, one second, yeah, 90.5. let me erase this one. That will give you 90.5. okay, so now if we solve this, okay, so delta TB, the formula is what? Delta TF, TB or TF is given, TF. So delta TF will be 273, that is the normal, that is 273 minus T naught, this is TF, is equal to KF. What's the value of KF? KF is 1.86, 1.86, right, into I1 M1 plus I2 M2. We'll substitute all the values here. So let me put one more line here. Okay, so now if we substitute here, 273 minus TF is equal to 1.86 into, what is the I1 value? I1 is 1.8, okay, into what is M1 value? 5.8 by 58.5 into 1000 by 94.2, okay, plus we have 9.5 by 95 into 1000, okay, by 90.5 into the I2 value is 2.2. okay, now we need to solve this equation and find the value of TF. okay, now if you solve this, you will find that TF value will be getting around 265. okay, so correct answer for this question will be option number B. I know this calculation will take a lot of time, so that is why I have given you almost 5 minutes for this question. okay, next one, a non-volatile solute A tetramerizes in water to the extent of 80%. 2.5 gram of A in 100 gram of water lowers the freezing point by 0.3 degrees Celsius. The molar mass of A is this much. okay, so you need to calculate the molar mass of A. This question was asked in 2019, so medium question because it has some calculation. okay, so wrong, you can do mistake in again calculation of the I value. okay, and the time required will definitely should be less than 1 minute. okay, so now let us do this question. We have what we have, 80% it is there, right, and this is given to you, freezing point is given. okay, let us note down the values first. Alpha is how much? 80%. okay, so alpha is 80%, then weight of the solute, or I can say W2 is 2.5 gram, W1 is how much? 100 gram. okay, next we have freezing point, delta TF is 0.3. okay, molar mass is, now we have to calculate, KF value is 1.86. okay, fine, this is done. Now let us substitute the values. So now first of all we need to calculate I value. okay, so what is the formula for I? I is equal to, sorry, alpha is equal to, so tetramerizes means there is association, I minus 1 by n minus 1. So I can substitute alpha is how much? 0.8 is equal to I value. I value I need to calculate minus 1 by 1 by 4 minus 1. That implies what? This is 3 by 4, 4 by 3. So 0.8 is equal to minus 4 by 3 will come. So I'll make it as 1 minus I into 4 by 3. 4 ones are 4.2s are 3 into 0.6 is equal to 1 minus I. So I will be equal to 0.4. Okay, I value will getting 0.4. So let me note down here 0.4. Now let us substitute. Delta TF is 0.3. Okay, delta TF is 0.3. I value is 0.4. KF value is 1.86. M value is 2.5. Okay, divided by molecular mass we need to find into 1000, okay, by 100. Clear? So now if you solve it, we'll get this one is 25. 25 into 4, yeah, we'll get 25. 25 4 is 100, but it will come around. So here we will get 25 into 0.400, that is 10. 10 into this 18.6, right? So M will be equal to 18.6 by 0.3, right? So that if you solve it, we'll get 62, right? So correct answer for this question will be option number A. Okay, next question. So you can see the formula, same formula we are using. Now question number 19, which of the following aqueous solution has the highest freezing point? Okay, 2015 question. This is very easy, but at the same time it is a tricky question. Formula, you know, freezing point formula we can use. Application based question, it can be, if you like the time when you are applying the formula, it may be wrong because the concept here is little tricky. See, they are asking you the highest freezing point. Okay, when you add a solute, what happens? The freezing point decreases, right? So that means wherever there is less decrease, that will be the having highest melting point, okay, highest freezing point. The solution where the delta TF value, like the decrease delta TF, the decrease is less, that will have the highest freezing point, right? So we need to check where this is highest, like where the decrease is least. Now if you see here, here I can say delta TF, our formula is what? Delta TF is equal to I into KF into M, right? KF is constant, we need to calculate I into M. Okay, so wherever IM is least, that means there the depression will be least, right? Suppose if you see, this is the general point. Okay, now suppose somewhere it decreased here, some in this much options it decreased in this way. So here where the decrease is least, that will have the highest freezing point. Okay, so that's what I'm saying here. If you see, if you multiply IF into I into M, will get 2 into 0.01, that is 0.02, and here if you get 2 plus 1 3, so we'll get 0.03. Now if you get sucrose, this will be 0.1. Now if you see this one will also be 0.1 into 2, 0.2, right? Now where you see the decrease is least, the decrease is least in 0.02, right? The depression is least in option number A. That means the freezing point will be highest here. So correct answer for this question will be option number A. Okay, now let us see the next question. The swelling in feet of ankles of an aged person due to sitting continuously for long hours is reduced by soaking the feet in warm salt. This is because of, so 2023 question, very easy question. This is osmosis. You should not take any mistake here. You should not, very easy question. Time taken should be around 15 seconds. Okay. Next question, which of the following colligative properties can provide molar mass of proteins, polymers and colloids? So in the application, question was asked again in 2022. For calculation of molecular mass, again osmotic pressure is used. So correct answer is option number B here. Next, if 3 gram of glucose, that is, if 3 gram of glucose, that is molar mass is given, is dissolved in 60 gram of water at 15 degrees Celsius, the osmotic pressure of the solution will be. See here again this question is easy, okay, but little tricky because of we know that what is the formula of osmotic pressure, C into R into T, where C is molarity, right? But here you see there is no volume given, right? There is no volume given to you, that is mass is given. So here you should remember, sometimes if the data of molarity, volume is not given, we can use the concept of molality and solve it. Okay, so in case of when the solvent is used, molality and molality can be used interchangeably. Okay, so what I can use, I need to use here molality. That is what can be confused with the students. Okay, fine. So let us now calculate what is the Let us first note down the values given. Okay, so we have what, 3 gram of glucose. So W1 is 3 gram. Sorry, W2 is 3 gram. Molar mass given dissolved in 60. So W1 is 60 gram. Okay. 15 degrees Celsius, temperature is 15 degrees Celsius, that means 273. So it is 285, right? 273, yeah, sorry, 288, right? Sorry, I did wrong calculation here. So it is 288. Okay. Okay. Next, coming to we need to calculate the osmotic pressure. Okay, let us do. I told you here you need to take molality. So 3 by 180 into 1000, okay, by 60. Okay, R is what? 0.083. Then temperature is how much? 288. So you have to use little calculation here you need to do. So once you do the correct calculation, answer will be option number A, that is 6.57 atm. Okay. Next question, this is the formula for osmotic pressure. You should revise this formula. Volume of the solution, if it is not given, you need to use molality formula. Okay. Now let us see the next question. Which of the following pairs of solution is isotonic? So this question was asked in 2020, easy question, osmosis. You should know the definition. If you know the definition of isotonic solution, then definitely this is an easy question. So now if you see, for isotonic, what should be constant? Pi value, osmotic pressure should be same, right? Now osmotic pressure will be same if I and molarity is same, right? Now if you see here I value is what, 5 and 0.001, so I will get 0.005, and here how much will get, 2 plus 1 3, so we will get 0.03. Okay, so these two are not same, so this cannot be the answer. Now here if you see I value is 2 plus 1 3 and this is 0.001, so we will get 0.003, and here it is 0.001 and here again it is 5, so we will get 0.005. I value is 5, right? 5 ions will be produced, so these two are not same, we can eliminate. Now if you see here 2 plus 1 3 and 0.01, so I will get 0.03 and 0.001 and CaCl2. So here also the I value is 2 plus 1 3, and if I multiply we will get 0.003. So again these two are not same, so we can eliminate. Last one, BaCl2, 2 plus 1 3 is there, and here 0.01, so I will get 0.03. And here NaCl, I will get I value is 2 into this one, so I will get 0.03. So these two are same, so correct answer for this question will be option number D here. Next, when the pure solvent diffuses out of the solution through the semi-permeable membrane, then the process is called as out of the solution. Okay, that means from low concentration to high concentration, that is called reverse osmosis. Question was asked in 2017, very easy, and there should not be any error here. Okay. Next question, osmotic pressure of the solution can be increased by. This question was asked in 2016. Also, this is a very easy question, and you should know what is the relation with volume and temperature, everything. So if you see osmotic pressure, right, pi is equal to C into R into T, right. So first of all, with respect to temperature, what happened? Increase of temperature will increase the osmotic pressure, right. So increase of temperature is the correct, because directly proportional, this one will also increase. So increase of temperature of the solution, that is a correct statement. Decrease will be wrong. Now what about volume? Now see, if you see here, concentration is one number of moles by volume. If volume increases, osmotic pressure will decrease. So that is why this is also wrong, this is also wrong. Diluting means also adding more water. So correct answer is option number A here. Okay. So let us see the next question now. 0.06% of aqueous solution of urea is isotonic with. Okay. So question is again from the chapter 20, was asked in 2017, medium osmosis. Isotonic definition you should know, that osmotic pressure is same. Time required should be within 1 minute. Okay. So now let us see what is the osmotic pressure of this solution. So we need what? Pi into C into RT. So 0.06%, right? That means 0.06 gram. Okay. W by V, volume is 100 ml. That means what is urea molar mass? 60, right, into 1000 by 100. Okay, so we will get how much this one? 0.01. Okay, so I should get 0.01 molarity. So if you get 0.06 glucose, okay, so will it be 0.01 molar? No, right? 0.6 by 180, you won't get anything around 0.01. Here 0.1 is given, 0.01 is given, so correct answer will be option number D here. Okay, R and T is constant, 0.01 m, there also we are getting 0.01 m, concentration is same, so osmotic pressure will also be same. Okay, next, isotonic solutions have again the same thing, they have same osmotic pressure. Okay, 2016 this question was asked. Next, dimerization of solute molecules in low dielectric constant solvent is due to. So this question was asked in 2023. Okay, so dimerization happens because of hydrogen bond, so correct answer is option number A here. Next question, which of the following aqueous solution should have the highest boiling point? Okay, so for highest boiling point what we need, I value should be maximum. Okay, if you remember highest freezing point, then I value should be minimum, but for highest boiling point I value should be maximum. Okay, so here I value is what, 2, here I value is 3, here also I value is 2, and here also I value is 2. So 3, that means correct answer will be option number B here. Okay, 2018 this question was asked. This is also very easy question. Within 15-20 seconds this question should be done. Now let us see the next question. The Van't of factor I accounts for. So this is a definition based question, 2016. It tells you about the extent of dissolution of the solute, extent of dissociation of the solute, extent of mobility, extent of solubility. Tells about the dissociation, right? So correct answer is option number B. You should be clarified about the definition of this. So common mistakes, if you do not know, if you haven't studied the definition, you may make, because there are some confusing terms like dissolution, dissociation, solubility. Okay, otherwise if the definition is clear, this is a very easy question. Okay, next question number 31. When an electrolyte is dissociated in the solution, the Van't of factor is. Okay, so here also from the definition only this question is there. For dissolution, Van't of factor will be greater than 1. Okay, so correct answer will be option number A. Question was asked in 2016. So for dissociation you should remember this one, and for association it should be I should be less than 1. Okay, fine. And next question. Okay, a solution of 1.25 gram of P in 50 gram of water lowers the freezing point by 0.3 degrees Celsius. Molar mass of P is this much. Kf value is given. The degree of association of P is. Okay, so this question I will put it in the difficult section because you might not remember the formula. This formula is not very commonly used, like colligative property is not asked directly, and calculation will also be taking some time. So somewhere in between moderate to difficult level. Okay. Fine, this question was asked in 2014. Okay, let us first note down the data that is required. Solution of 1.25 gram of P in 50 gram of water. Okay, so we have mass of the solute as 1.25 gram. Okay, and we have the mass of the solution, that is 50 gram. Okay, lowers the freezing point. So we have delta TF as 0.3. Okay. Molar mass of P is also given to you. Molar mass of P is 94. Okay. Kf value is 1.86 Kelvin kilogram mole inverse. Degree of association of P. Okay, you need alpha association. So for that, first we need to calculate the I value. Okay, so what's the formula we know? Delta TF is equal to I into Kf into M. Okay, so first we need to calculate the I value. So let us say delta TF is 0.3. Okay, I Kf value, so let me do it. 1 second, we'll take a better space and start solving. Okay, see here, delta TF value is, we have this formula, delta TF is equal to I into Kf into M. Okay, delta TF value given to you is 0.3. Okay, second. Okay, next we'll put all the values here. 0.3. Kf value is how much? I value we need to calculate. Okay, Kf value is 1.86. Okay, molality value is 1.25. Okay, by molar mass is 94. Okay, into 1000. Okay, divided by 50 gram, right? Solution W1 is 50 gram. given mass by molar mass. Molar mass of P is 94. Okay, now we can solve this question. It's a lot of calculation here, so let us do this one. We can solve, we'll get 520. Okay, if you do this calculation, we'll get I value around 0.6. okay, so now what you have to do, you have to calculate alpha value, right? What is alpha value? Formula I minus 1 by n minus 1, right? Now here it is not told that dimerized, atomized, nothing is given, so in general you can take it as dimerization. Okay, so what will I get here? Alpha value will be I value is 0.6, right, minus 1 into 1 by 2 minus 1. So this one will give me 0.8, then into 100, for if you multiply with percentage, we'll get 80%. So correct answer will be option number A here. Okay, so this formula for association you need to remember. Okay, so students, these were some top 30. I have taken 32 questions that were asked in the previous years. Now what you have to do is, first you have to solve this 32 questions, and then you have to practice similar type of questions. Okay, many a times I have got comments like, ma'am, are PYQs enough? Are PYQs enough? PYQs are enough to understand what type of questions are asked, but you need to do more practice of similar type of questions so that you can master the topic. Okay, so I hope this video was very helpful for you, and if you have any doubt in any question, please do not forget to comment down. I'll definitely address it. And thank you for watching, and if you're following this series, if this series is helping you in your KCET preparation, please do not forget to subscribe the channel. Okay, and please join our WhatsApp channel and also join our Instagram. So the link of the Instagram account will also be given in the description section. Please go and join the Instagram channel also. You will find many academic content there. Okay, so thank you, and once again all the very best for your KCET 2025 preparation.